I'm Jeanette Wider, and I am a managing editor of Healthcare Innovation. Today, I am here with Nick and Richard to have a little discussion about artificial intelligence. So, I'd like to begin with the two of you gentlemen introducing yourself. So, why don't we start with you, Nick?
Good afternoon. My name is Nick Manali, and I am the data officer at Johns Hopkins Healthcare.
And my name is Richard Kramer. I am the chief strategist for healthcare and life sciences at Informatica.
Great. Okay, so I'm going to hop right into this. So, artificial intelligence and machine learning are used almost everywhere, but for vastly different reasons. So, today, when we're talking about artificial intelligence, what exactly do we mean?
Nick, you want to take a stab at that first?
Yeah, absolutely. I think AI and ML are simply the next evolution of software development that's been enabled by the improved capabilities that we have today, and also the software development languages such as Python and R have enabled data scientists to perform development that, quite frankly, wasn't possible or quite as easy with previous software development tools. So it's really just the next evolution in software development capabilities.
Yeah, and I would add to that, Nick, right, that AI and ML first are used interchangeably and used to apply to everything. And so in preparation for our discussion today, I did a little bit of a survey of how it's being used and what people are talking about, because I am not an artificial intelligence expert nor a pundit, right? And when you look at it, again, they're used interchangeably, but typically you think of machine learning as being the process when people want to predict something. And most of the use cases, and we're going to talk about some of those today, are really about being able to predict something in the future based upon data and analytics and things that we've done. And as Nick described, it's really the availability of large amounts of data, the availability of cost-effective, massive amounts of computing power, and then the variety of techniques that we're able to do around free text and images and those sorts of things that all come together under this overhead or this umbrella label of AI and ML that really is what's coming to market. And it really doesn't matter what the precise definition is. We're going to talk later about, people really care about the outcomes and why it delivers value, not the precise definition of the technique. So I completely agree with Nick's position that it really is just the next evolution of computing.
Yeah, and I'll just add a little bit more to Richard's statement there that, as he said, at the end of the day, from a technical perspective, it really doesn't matter. All the business cares is that we are solving their critical business problems.
Okay, so Nick, you're the CDO for a payer, and maybe you can give us an example or two about where AI is being used in your organization specifically.
Yeah, absolutely. So there's a couple of use cases that I could highlight. One of the biggest ones that we're doing is around the area of payment integrity. So what is payment integrity? I think most people know, but it's like the precursor to fraud, waste, and abuse. Fraud, waste, abuse is pay and chase. Payment integrity is stopping improper payments or incorrect payments before they happen. So we've implemented about 17 sets of algorithms here at Johns Hopkins Healthcare that consume and interact with approximately 340 different data elements. It's claims data, member data, provider data, really pretty much everything that we have from a data domain. And we look at things like coordination of benefits, improper billing. As we all know in healthcare, durable medical equipment is just prime for not fraudulent billing, but just inaccurate billing. Also things like subrogation, right? Somebody's in a car accident. That's kind of similar to COB. And so those are some of the things we're doing with AI. You may ask, well, why do you need AI for that? Well, a couple of things. There's just so much data that to manually sift and sort through that would just take an inordinate amount of time and a lot of people. And, once these algorithms are written, they just run. They just run every day and they produce output. And then, yes, a human has to, kind of, do a final review and, do checks and balances and look at things. But we would just have to hire, a tremendous amount of people to manually, look at it. Again, as I mentioned, it's a proactive approach, right? So that saves us money. We don't have to pay something incorrectly and then chase it, which, that costs money. So there's a very good return on investment by running these algorithms in this, proactive manner.
And Nick, what's intriguing about your definition, right, and the distinction, right, that fraud, waste, and abuse has been around for a long time. And because you're paying, and all of the people who should be appropriately paid are, then they're happy. And so the fact that you are doing it retrospectively and chasing the bad actors, that was fine. We would always have wanted to, wow, it's always better to keep from paying the bad actors rather than having to, as you said, pay and chase. Well, why haven't we always done payment integrity ahead of time? Well, because you have to do it really accurately, because you don't want false positives. You don't want to not pay people who should have rightfully been paid, right? And so your algorithm needs to be far more accurate if you're going to stop somebody from being paid, because you don't want to not pay the people who should have been. And the time requirement to do it quickly so that you can, in fact, pay the people in a timely manner who should be paid. So this is a perfect example of where you started the conversation, that, because we're able to do this on a larger volume of data, 300 and some different data elements, and do it at scale and fast, is really the benefit that we're seeing. And let's call it machine learning, which is a subsector of AI. This is that. Right? It's a very pragmatic example where, because we can do it so much more accurately at such greater scale, consuming so much more data, we actually get to do it up front and keep from paying bad actors rather than paying and chasing. And that's a perfect example of the value what that AI is delivering.
Yeah, and just to expand upon the accuracy component, as you can imagine, if we don't do this accurately, the provider abrasion would just be tremendous, right? Because if we don't pay something timely, that certainly has consequences, right? So with AI, we're able to, fine tune the algorithms to be, very accurate, and reduce it, if not completely eliminate the abrasion. There's still always some people that get upset, but we're greatly able to reduce that.
Right. And Nick, your point about saving money, I don't think any organization would say they don't want to save money. So it's very good.
Yeah, absolutely. It's a great, time saver and financial return on investment on saving, funds, which ultimately still, is all about then enabling us to use our funds to greatly serve our members in other ways.
Right, right. So artificial intelligence and machine learning certainly get a lot of airtime in the analytics and technical communities. But what are you hearing from the business side and the clinical side for both of you?
Well, one of the biggest challenges with data, and I'm not the first to say this, is, around data quality, right? They're looking for business problems to be solved. They don't necessarily care, and maybe care is the wrong word. They just want us to solve business problems. And whether we do it with AI or ML, sometimes when I start using those buzzwords, they glass over. And they just want us to solve things faster with better quality and reduce our costs, like we were just talking about with payment integrity. And so that's really what the businesses cares about. At the end of the day, whether it's AI or ML or another buzzword, just solve the problems quicker with better quality and reduction in costs.
And I think that take what you said, Nick, and from the vendor perspective, amplify it by the thousands of different companies that the vendors try and approach, right? Every vendor has AI and ML story, right? You know, somebody with a toaster is going to tell you how their toaster is going to make perfect toast because of AI and ML. And so from the vendor perspective, it's almost a negative to lead with an AI or an ML perspective. As Nick described, you want to lead with, and you want to talk about the outcome. I'm able to predict, the census better. I'm able to predict what customers are going to churn. I'm able to predict, things that matter to the business. And whether or not it's AI or ML, they don't really care about. Now, when you start talking to the chief data officer, the chief analytics officer, there is a component of how are you doing this? And they're intrigued because they're technologists and they like to understand how these emerging techniques and capabilities are integrated with the vendors and the products that they use. But as Nick said, from a business and clinical perspective, it's the outcome and the value that people care about. And it's almost a negative to mention AI or ML because, as Nick said, their eyes roll back in their head, their vision clouds over, and they don't want to listen anymore. So we don't really ever lead with AI and ML from the vendor side.
Okay, so in healthcare, when we hear about AI and ML, we do tend to think about the business and the clinical side. Are these the only places in healthcare that we can apply AI to?
So this is a chance for me to talk from a data management perspective, right? And as you asked, we typically think of, we're going to use AI to predict ICU census, or we're going to use AI for payment integrity, all of those sorts of things. And they're great use cases for AI. But at Informatica, we like to say that AI needs high quality data and high quality data needs AI. And what we mean by that is there's an enormous opportunity to employ artificial intelligence and machine learning as part of data management, right? And if you look at the volume of data, the complexity of data, the different uses of data, all of those things are exploding. Plus the obligation to get insights from it to do the types of things that Nick has described. Well, when your data volumes double, you're not doubling your IT staff. When your variety of sources quadruples, you're not quadrupling your IT staff, right? We're always talking about doing more with less. And so what Informatica is doing is we're applying artificial intelligence and machine learning to the challenges of data management. And we're really doing it in a couple of different ways. One is what we call operational insights, which is how do we use our knowledge of how data is running through your system in terms of what data it is, what volumes it is, what are your service level agreements in terms of processing that data, and how do we use AI to recognize disruptions in that data? We're getting new data that we didn't expect, right? From a technical perspective, think of a slowly changing dimension in a database. So something is changed in that data that's coming in. How do we react to that and create a resilient data processing system? Well, we do that with artificial intelligence and machine learning, looking across the literally trillions of transactions that our intelligent data management cloud is processing to say, we've seen something like that before, respond this way, right? To identify exceptions, we can look at your service level agreements and say, the data volumes are going up, we need to spin up more capacity, right? Using AI and ML to create a much more resilient data processing environment than we would have had in the past, right? Because hard coding this stuff creates a very brittle environment that anytime something changes, everything breaks. So AI and machine learning and operational insights changes that. And then the other thing that we're able to do, and a good example, Nick, you had brought up data quality, is the idea that says, how do we create guidance that makes it easier, more productive, and faster for analysts and people who are building data integrations and data quality rules to do the right thing, right? And again, from this trillions of different transactions that we look at, we say, have we seen this type of data, this pattern before? And what data quality rules across all of our customers were applied to that particular pattern? And we're able to recommend, hey, use these different data quality patterns against, or rules against, this particular pattern. So again, applying that machine learning to be able to make data management far, far more efficient and allow your scarce, very talented staff to focus on the things that are really complicated and need their intellect and decision making, while we automate using AI and ML the more routine things.
Yeah, Richard is spot on about the data quality component. When I first started here about 5 years ago, I set up meetings with, the executives, with the data scientists, everybody, and there was a theme: data quality, right? And so, honestly, the data quality just wasn't there. And we've invested a lot of time in this area to improve the data quality. It's so important at our organization that it's a corporate goal. And so we have produced, tactical weekly metrics that go out, at a lower level. But then I'm responsible for reporting those metrics to our executives on a quarter basis, and it's shared with all the executives. And so we've implemented various data quality, AI, and ML algorithms and rules. And no good deed goes unpunished. Last year, I was able to improve our data quality by 26%. Exceeded the goals, and they said, thank you very much. Next year, you got to do better. But I love a great challenge. And so, through this technology, I can say we are beating last year's goals, and we're able to do it, with these technologies. And, at the end of the day, if you don't have good quality data, well, then you're not going to get the ROI for those business use cases. So,
yeah, and I think, Nick, it's very valid, right? If we look at AI and ML, first off, you need good quality data to train your AI and your machine learning so that it's accurate. And well, what if you use bad quality data? AI and ML actually amplify the impact, the adverse impact of poor quality data. So even more so, and I mean, every healthcare organization has always valued high quality data because it impacts patient care. But when you start adding in AI and ML and its amplification of the impacts of poor quality data, it becomes more important. And then also, just the transparency, right? There's a lot of concern about the adverse impacts of poorly trained AI and ML in terms of not recognizing health equity or disparities in underserved populations, and perpetuating, if we have data in the past that had bias, how do we identify that? How do we monitor these AI and ML algorithms as they're being deployed? And a big part of that, and it's not necessarily machine learning for data management, but it's the transparency of knowing where the data came from and what the characteristics of that data are that were used to train the AI and the ML algorithm. And that idea of the end-to-end transparency is a critical component of data management, right? If I can't explain the data set that was used to train a particular algorithm and make it inspectable, then we should always suspect whether or not that algorithm is appropriate to use. And one of the things I like to say as a longtime data analyst is that if you are transparent, I can trust your conclusion even if I disagree with it, right? If you're not transparent, even if I agree with you, I can't trust you. And so, and it's amplified again when we talk about the value of this end-to-end data management platform, is being able to provide that transparency that engenders the trust that allows us to rely on the high quality data to deliver the algorithms and the value.
Yeah, absolutely. And part of that quality and that trust is being able to illustrate, the lineage of how did you get from A to Z because a good data scientist wants to know, all of those characteristics of that data.
And the weasel words that have historically lived, right? I don't know, I think, it might, probably, none of those words are adequate when you're talking about, an algorithm you're rolling out at scale across an enterprise the size of Hopkins, right?
Yeah, absolutely.
No
Absolutely.
weasel words allowed.
No, no.
Especially in healthcare, right?
Exactly.
No room to say, I don't know, when patient safety is on the line. So this is all really interesting, but when it comes to AI, what's next?
I think there's a lot of possibilities. AI and there's no one perfect answer for that, right? But what I'll say is AI and ML needs to continue to enable whatever the best use cases are that our business needs to solve, right? We need to get to make transformative decision making easier, quicker, faster, reduce costs, and at the end of the day, improve the lives of our members, because that's really what it's all about, right? Um, and furthermore, there's just a plethora of data in healthcare. Yet, as a payer, the most of it that we get is stuck in silos, and it comes to us from a billing perspective. And so, to enable AI and ML to be even better, we need to get more data, right? You're probably not surprised I said that, right? On the one hand, my God, we have petabytes of data, but it may not be the best, right? And so, for example, is somebody was in the hospital and they get the white coat syndrome, and so that's why their BP's higher. But we don't have that metadata because you don't get that in the billing. So more metadata, more social determinants, more data that will enable AI to make even better, transformative decisions. The next great thing is to expand data accessibility. The federal government has done some great things with programs like CMS interoperability. EMRs, we could argue, just locked it up. CMS interoperability is trying to unlock it. It's a great first step, but it's not quite there yet. But you have to start somewhere. So the next great thing is going to need more data, more metadata, which will enable our data scientists and data analysts to just make those deeper, get deeper understanding about our members and patients.
Yeah, and Nick, you raised a variety of great issues, right? The idea of more data, and there's lots of evidence that shows that the data from an EHR, or particularly the data from a claim, is actually not particularly useful in predicting an outcome or a readmission or an adverse event. Some of the most predictive data that you can use is social determinants of health. Does somebody live alone? Do they have a car, right? Things like that tend to be more predictive of some of the things we care a lot about. And so that's part of the more data and the more variety of data. I think there's the issue of context, and you raised this, Nick, right? And blood pressure is a great example. Blood pressure, are you standing up, sitting down, lying down? Is that, how was the blood pressure taken, dramatically influences whether the value can be compared to other ones. And when you're sitting in the office entering the data into the EHR, it's no problem. You're assessing, is it normal? Is it not normal? If it's not normal, you take it again. But when you're doing secondary use of that data, 3 months, 3 years down the road, as part of building and training an AI algorithm, knowing the context of how and when that data element was taken becomes critically important, right? Even something as pedestrian as, is the doctor's office on the ground floor or the second floor? Because gadzooks, maybe they walked up the stairs before you took their blood pressure, right? Similarly, if we look at medical device manufacturers, they all have an interest in being able to come up with predictive models on what's the best procedure for their device. What device should you use? They're getting tick by tick data, no pun intended, from pacemakers after the pacemaker's implanted. But they don't have context. Are you lying in bed at home and have a heart rate of 180? You probably maybe should be concerned. If you're at the gym exercising, perhaps not a big deal, right? So the idea of, if we're going to really make use of all of this data to train AI and ML algorithms, we have to capture and perpetuate the context with which that data was created, so that we can actually identify the signal from the noise later on. And then, to bring home my context from Informatica, and we look at, how we're applying AI and ML for data management, we're in the early days, right? And it's not Informatica, the industry is in the early days of really seeing, what the value of AI and ML can be. It's an area of enormous investment for us, and how we can go from things today where we're using AI and ML for guidance, but there's still a lot of manual intervention. And part of that is culturally the trust, right? I'm not quite ready to trust a machine to make that decision for me. But as we get better, as we include more data, as our algorithms become more predictive and more accurate, I think we're going to see the opportunity to really, amplify the productivity of AI and ML in data management by virtue of literally automating, lights out automation of a lot of the functions today that we're just sort of getting started.
Right, very interesting. I recently read a story about AI and ML and it coming into healthcare, and a few people being like, oh, I don't really know. And a lot of the answer to that, to calm people, was it's just a tool. You're still the doctor, you're still the clinician. This is a tool, so you have more time to be a clinician. So I really want to thank both of you for joining me here today, talking about such a complex and interesting topic. It was fascinating.
Well, thank you.
And thank you. I enjoyed it today.